Hello, this is not your chem tutor, and in this video, I will be teaching you about combined gas law. But before you continue with this video, make sure you are familiar with Boyle's law, Charles' law, and gay-lussac's law. Why? You will see later on. If you are not familiar with those gas laws, don't worry, I made a separate video and you can check those videos using the link on the description box. As usual, I put examples so we can practice some calculations later on. Let's figure out first, why is it called combined gas law? This is because it is a combination of three gas laws. We have Boyle's law, P1V1 equals P2V2. We have Charles' law, V1 over T1 equal to V2 over T2. And we have gay-lussac's law, P1 over T1 is equal to P2 over T2. When you combine these three gas laws, you form the combined gas law. And the formula is P1V1 over T1 is equal to P2V2 over T2. So as you can see, this part right here is Boyle's law. And this part right here, V1 over T1 equal to V2 over T2. This is your Charles' law. And we have P1 over T1 equal to P2 over T2. And this is your gay-lussac's law. So that's why you call this combined gas law. Now let's define each term in the formula. Let's start with P1. This is your initial pressure. And P2, of course, is your final pressure. Just a quick note or a reminder, for pressure, P1 and P2, you can use any unit. It depends on what is given in the problem. But remember, you need to be consistent in using that unit. So for example, if you use ATM for P1, make sure you are using ATM for P2. If you use Pascal for P1, make sure it's Pascal for P2. Okay, again, any unit for pressure as long as you are consistent with that unit. Now let's move on to V1. This is your initial volume. And V2 is your final volume. Same with pressure. You can use any unit of volume. But again, you need to be consistent. If you use ml for V1, make sure it's ml for V2. If you use liters for V1, make sure you use liters for V2. Okay? And finally, let's move on to the temperature. T1 is your initial temperature. And T2 is your final temperature. Oh, I forgot to specify. It must be absolute temperature. So T1 is your initial absolute temperature and T2 is your final absolute temperature. So again, what do we mean by absolute temperature? It's temperature in the Kelvin scale. So for our third note, for temperature, you cannot use any unit because the formula is very specific. It's absolute temperature. So for temperature, use only Kelvin or K. Okay? So for our first example, a gas has a volume of 50.0 ml at 15 degrees Celsius and 175 torr. What would the volume of the gas be at 75 degrees Celsius and 400 torr of pressure? So in this type of problem, in combined gas law problems, it is helpful to list the given. So let's identify first the P1, V1, T1, and the P2, V2, and T2. So if you read the problem, we are given P1, which is 175 torr. We are also given the initial volume, 50 ml. And T1, we are given 15 degrees Celsius. But as you know, in combined gas law, temperature must be in Kelvin. So we need to convert 15 degrees Celsius to Kelvin. And how do we do that? If you want to convert Celsius to Kelvin, you just add 273.15. So our temperature in Celsius is 15 degrees Celsius. You just add 273.15, and that is equal to what? That's equal to 288.15 Kelvin. So this will be our T1, 288.15 Kelvin. Then we are also given P2 in the problem, 400 torr. And we are given T2, 75 degrees Celsius. But again, you need to convert it to Kelvin. So you do 75 plus 273.15. So for T2, that's 75 plus 273.15. That is equal to 348.15 Kelvin. So this is our T2. V2 is not given in the problem. So if you read the problem, there's nothing there that says V2. So this is unknown. So in this problem, we are actually looking for V2 because it says what would be the volume of the gas. So we are looking for V2. So we will be using the combined gas law. This one, P1 V1 over T1 equal to P2 V2 over T2. So what you need to do is you just plug in the numbers. So let's do that. 175 torr times V1, 50 ml, divided by T1, 288.15 Kelvin, equal to P2, 400 torr. V2 is unknown, so just write V2, divided by T2 is 348.15 Kelvin. So what you can do is you can cross multiply. So your equation becomes 175 torr times 50 ml times 348.15 Kelvin equal to 400 torr times V2 times 288.15 Kelvin. To solve for V2, you can divide both sides by 400 torr times 288.15 Kelvin. And you do that same thing to the left side. So divide it by 400 torr times 288.15 Kelvin. So what happens is that on the right side, 400 torr will cancel out, 288.15 will cancel out. So what remains on the right side is V2. And on the left side, as you can see, torr will cancel out, Kelvin will cancel out, and you are left with ml. And if you're going to solve this in your calculator, so you just type 175 times 50 times 348.15 all over 400 times 288.15. The answer I got is approximately equal to 26.4 ml. And this is the answer to example 1. Okay, let's do the second example. A 2-liter balloon contains oxygen gas at 101 kilopascal and 298 Kelvin. If the balloon is compressed to 1.25 liters and the temperature is lowered to 283 Kelvin, what would be the pressure inside the balloon? So again, the first step for combined gas law problems is to list all the given. So in the problem, we are given P1, which is 101 kilopascal. We are given V1, which is 2 liters. T1 is also given, and it's already in Kelvin, so we don't need to do any conversion. It's 298 Kelvin. P2 is not given in the problem. Actually, it's the missing variable because the problem says what would be the pressure. So we are looking for the final pressure. V2 is given 1.25 liters and T2 is also given 283 Kelvin. So it's already in Kelvin, so no need to convert it anymore. Let's proceed to the substitution. So we use the combined gas law. P1 is 101 kilopascal. V1 is 2 liters. T1 is 298 Kelvin. This is equal to P2, which is unknown, so just write P2. V2 is 1.25 liters and T2 is 283 Kelvin. So you can do cross multiplication. So this becomes 101 kilopascal times 2.00 liters times 283 Kelvin equal to P2 times 1.25 liters times 298 Kelvin. So to solve for P2, you can divide both sides by 1.25 liters times 298 Kelvin. So do that also to the other side. So what happens on the right side? 1.25 liters will cancel. 298 Kelvin will cancel. So what is left on the right side is P2. On the left side, liters will cancel. Kelvin will also cancel. So the remaining unit on the left side is kilopascal. So if you solve this in your calculator, you type 101 times 2 times 283 divided by 1.25 times 298. This is equal to approximately 153 kilopascal. And this is the answer to the question. For our last example, if the pressure is reduced to 1/4 of the original pressure and the volume is increased to twice of the original volume, what happens to the temperature of the gas? So let's dissect the problem. First, it says the pressure is reduced to 1/4 of the original pressure. So that means the final pressure is 1/4 of the original pressure. P2 is 1/4 of P1. Then it says the volume is increased to twice of the original volume. So the final volume is twice the original volume. So V2 is equal to 2V1. And then we use the combined gas law. So the combined gas law is P1 V1 over T1 is equal to P2, which is 1/4 of P1. So instead of putting P2, you put 1/4 of P1 times V2. So instead of putting of V2, you put 2V1 divided by T2. And then you can do cross multiplication again. So if you cross multiply, you will get P1 V1 T2 equal to 1/4 P1 2V1 times T1. Next, you divide both sides by P1 V1. So on the left side, P1 cancels out, V1 cancels out. So what remains on the left side is T2. On the right side, P1 cancels out, V1 also cancels out. So what remains on the right side is 1/4 times 2 times T1. And what is 1/4 times 2? 1/4 times 2 is equal to 1/2. So the right side becomes 1/2 of T1. So the answer to this question is T2 is equal to 1/2 of T1. Or in sentence form, you could say the temperature is lowered or reduced to 1/2 of the initial or original temperature. Or simply, T2 is equal to 1/2 of T1. And this is the answer to the question.